So 4.4a, where we left off Tuesday, we are basically going to go from fraction form to decimal form. Okay. Let's look at that first example there. It says number 4, but first example on this sheet is convert 3/16 to decimal. Okay. And we know that if we're looking at a fraction, like 3/16, we can read it as an operation. How would we read it as an operation? 3 doing what with 16? Dividing, right? 3 divided by 16, we can read that from top to bottom. So 3 divide 16, and you see on the paper all of the longhand form of doing that division. I would, encourage you to take a look at that. But if that gets you bogged down or takes too much time, don't do that type of thing. What I am more interested you do in a situation like this is use your calculator. And so get out your calculator and look at 3 divided by 16. What do you see? Good, thank you. 0.1875. So what have we found? You convert 3/16 to 3/16 to decimal. That is that decimal that we just found in our calculator. Now let's kind of do a little bit of recall from Tuesday. What is this? This is in addition to what you see on your paper. I'm just throwing in some extra here. This is extra. Round to the thousandth place. Which number is in our thousandth place here? Which one? That's the tenths. Right after the decimals, tenths. And then counting from the hundredths, and then thousandths is where that 7 is, okay? And so that would be the place which we're interested in reporting our final answer. What would we do? Look at its neighbor to the right. This is 5. What do we do? Go up with that, and so it is 188 to the nearest thousand. Yeah, this is the tenth place, hundredth place, thousandth place. So there's a 1/10, an 800th, and a 7,000th. This is the ones place. Yeah, over here. The 0 is technically in the ones place for the unit. Yeah. First place to the right, or after the decimal, starts from 10. We don't have a ones or units place when we go to the right, just to the left. Good question. When we're going to the left, you do ones, tens, hundreds. Going to the right, start from tenths, hundredths, thousandths. So let's do number 5 from the quiz items. It says to convert 13/7 to decimal form. What is that? 13/7. Yeah, so do that in your calculator and confirm with me this result. But a lot, isn't it? 857 142 857. So this looks like it's repeated here. Some of the, or all of those items say if it's a repeating decimal, to place a line over the repeated part. And so that can be accomplished like that. Because notice we start to see repetition here, 857. And so 857, we would continue to see 1, 4, 2. If we looked at more decimal places, our calculator doesn't show us all of those, but that's what's repeated over and over again. But that's not likely to be something you need to report, like in survey or college algebra. What's more likely to be the case is to round. So let's round to the nearest hundredth. 1.9 is nearest tenth. We did perfectly nearest tenth. What if I'm asking for nearest hundredths? $1.86. That is the hundredth place going out to decimal places. That is the nearest hundredth. Now you might be asked both of those questions, not necessarily on the same item, but you might have items that ask you to round to the nearest tenth. Your answer would look like that. Or you might have other items that ask you to round to the nearest hundredth, and that would look like that. Just as a recap, if we're looking at tenths, then the next neighbor there is 5, so this will go up to 9. If we're looking at tenths, if we're looking at nearest hundredths, then we go out here and eyeball that 7. That also indicates to round this up for nearest hundredths to 1.86. So that place right to the left of the decimal can be referred to as the nearest whole number, the nearest unit, the nearest dollar, the nearest foot, whatever the measure is. If it says the nearest that, then you look to the ones place. Rarely does it say round to the nearest ones. It would say whole number, unit, or whatever the unit is, like nearest dollar, nearest mile. Yep. Now, if it wanted you round to the nearest thousand, then that would be different, right? 22,454.879 round to the nearest thousand. Not with the TH at the end. Then we're doing this way, ones, tens, hundreds, thousand. We look to the 4. And then we say, okay, I'm going to keep it at 2. And then I have to put in placeholders here, right? Yeah, then you're looking over to the left from the decimal.
I'm saying, what if they don't have that? Just like this, like say
Yeah.
they got 525 or
Mm-hmm.
say go to the nearest.
Yeah, if I didn't give you this decimal part, then that would be exactly the kind of question you're asking. How do I do that? Same way. Yeah, same way, basically. 4 is my ones, 5, 10, 400, 2000. I'm looking at the thousands place. I do it pretty much the same way if I don't have that decimal part. Mm-hmm. 500. Yep. Because the 2 is in the next place, so you don't round up to 600. You say 500 in that case. Yep. Mm-hmm. Absolutely. Those are some really good clarifying questions. Good. Mhm. So in the next part, we're basically going to go the other direction. Part B of section 4.4, we're going from decimal to fraction this way. So let's look at the example posed there, converting 0.368 to a fraction. Here's where our understanding of those labels really makes a difference. Tenths, hundredths, thousandths is the last decimal place represented here. So this is going to be a fraction in terms of thousands. That last, however many going out here. And you can kind of see there's a mapping between how many digits and how many zeros we have here. Thousandths corresponds to 3 digits. And then we place that on the top. You can see in the example, they broke it out into prime factorization. You don't have to do all that. Like we were talking about earlier, you found a 4 in that example, remember? You know, we could find an 8 in these and do that. Or we could just divide by 2 over and over again. Let's apply that strategy instead. Because I don't really see the 8 in there immediately, honestly. I would start by dividing 2. And then I would get 184 over 500. And as long as this last digit is even, what's happening? There's still a 2 in there. Yep. And so let's do it again. We get 92 and 250. So there we go again. We've got 2 still in there. And you can do this as long as you need. 46 over 125. Oh, but look, that's odd on the bottom. So we got all the 2's out. You might want to check for some 3s, 5s, and 7s and other stuff. But once you do that, you'll find that there's nothing similar in those two numbers. So that's our final answer. I do that just because it's easier. Yeah. And then once I've gotten all the twos out, like right here, then I might go in my calculator and divide both these numbers by 3. If it works, then divide the 3 out. If it doesn't, then try other numbers like 7. How do you know when to stop? Yeah, how do you know? We could divide 3. 4 is not necessary, like all the even numbers, right? Because we've already taken all the 2's out. So don't waste your time dividing higher even numbers like 4, 6, 8, 10. Do like 3, check for 5, check for 7. You can check for 9, but we've already checked for 3. 10, don't need. Check for 11, check for 13. 15, we've already checked for 3 and 5. Somewhere along the way, you're just going to have that gut feeling that you've gone far enough. And I would say by 13 or so is a good stopping place usually. There's a rare chance you might have 17 in both of them if they're really big numbers. Yeah. I know that's kind of a gray area. Where do I stop? Okay. What? Yeah. I'm just telling you that if we check for 3, 5, 7, 11, 13, 17, none of those divide either of those two numbers. Yep. Let's find another one. 3.25 there on the front page. Convert 3.25 to fraction form. We got a whole number though. So the way we would handle this is we would keep that whole number out to the side and then operate with the fraction. What's our bottom number going to be here? Two digit, what? 100. Because it's got 2 zeros. And 25 goes up here. What could we divide out of both of these? 5. Keep that 3 along, and then reduce your fraction. We get 5 over 20. Can we divide any more out? What? Another 5's in there. 3, 1 over 4. Yeah, we could divide 5 twice. Or we could have divided 25 in the beginning. Divide 25 here, we get 1. Divide 25 here, we get 4. So you can go either way. I don't always recognize those big numbers in both top and bottom of the fractions. But feel free to use the smaller ones. But just do it until you get to something clearly all the way simplified. Let's try that last quiz one. It says 0.00032. The fraction, what's our denominator? Go with a 1. How many zeros do I need? How many? 5 zeros. However many places you got here in this decimal, you need that much in your denominator. Yep, yep. That's the clearest way to get to the fraction form, in my opinion. You can go back to your original chart and look to see that this is the 100,000ths place. But I think that mapping is easier just to keep in mind for quick use. And then we replace 32. What's going on if I do this? Do those zeros mean anything? Not for whole numbers, right? So we don't need to write those down necessarily. Anything these share? Divide what? Go ahead if it's an option. Yep. So 5. So you went all the way. Yep. And these still are even, so we're going to divide 2 again. Get 8 over 25,000. Looks like those are even again. So we get 4 over 1,2,5,0,0. And again, 4 over 12,500. Divide 2 here. We get 2 over 6, 250, right? And then, but those are even. So divide 2 again, and we get 1 over 30,175. And that was from dividing 32 on both top and bottom. So long as it is a factor of the bottom number, then it will divide evenly. Yep. Mm-hmm. And 32 happens to be a factor of 100,000. So you can check that at the beginning of reducing a fraction. You can always say, hey, I'm going to try dividing this number by 368. But that doesn't work on this one. I'm going to divide this number by 32. It does work. So divide both by 32, you get 1 on the bottom, 3175. 1 on the top, 3175 on the bottom. So let's compare. Looking at that first example, we've got 0.3 versus 1/4. Any ideas on how we can get them to where they look similar and therefore then compare them easier? You could convert this one to fraction. That's one option. 3/10 versus 1/4. Getting somewhere, but still not an easy comparison, right? We would need to scale both of these up to want something over 40, right? Any other thoughts on how we might approach this? Like multi, oh, you tell me what you're thinking. Sorry. Tell me more. Like that way. That 3 times what? Like like we were multiplying fractions like this way. Mm-hmm. Trying to get a clear idea of what you're thinking. We can, right? However, it's not going to give us good information. So tell me more about that idea. What would you divide? If we want to continue this route, yeah. So let's do that. They have to equal the same thing on the bottom. What makes sense for a number on the bottom? Not the same number, but we need to get this number to be the same. 10 could go up to something, and then similarly, 4 could go up to the same number. Which one? 4 times 5. Okay. And 10 times 2, is that what I heard? I think that'll work because that gets both of them to 20. And then we would need to multiply the similar numbers on the top. 1 times 5 and 3 times 2. So this is similar to what we saw last week when we multiplied or scaled up fractions to the same denominator. And we see now clearly that one's greater, since 6 is greater than 5, and they're comparable on the bottom. Let's go a little bit different direction than what you see on the paper and say, I want to keep it in decimal form. What is this as a decimal? One divided 4. 1 divided by 4. Enter, forget, 0.25. Which one's greater? 0.3. Just compare. Yep. Good. Good additional thinking there. This is technically a 0. We compare the first digit, and that tells us this one's higher. 30 is higher than 25, is another way of looking at that. And so we got at the solution similarly, but with decimal that way, right? So either way is an option. I would advocate for that way, being more efficient. Let's do number 3 on the quiz items. We're going to compare 0.75 to 29 over 40. What do you want to do? You could take either approach. Do it again. We got to get them in similar format, so we can either do to decimal or to fraction. Okay. Good. So Rita, if I wanted to do them both in decimal form, what would I do with the fraction one? How could I get that one to decimal? Mm-hmm. So to get this in decimal form, type in for me just 29 divided by 40. There you go. 0.725. Good. So all you have to do to convert the fraction to the decimal is think of it as dividing. Yep. Yep. And now we're ready to compare them. 7 is the same, 5 is higher here. That 5 on the end over there doesn't matter, really. If it helps, you can do a 0 here and say 750 is higher than 725. So we can trace that back to the beginning, and that's the relation between those two. So anytime we want to compare a fraction to a decimal, take that fraction, just make it a division problem, see what you get in your calculator, and then you can do that comparison. The next section says ratio and rate. Those are just fancy words for fractions. A ratio is a fraction. A rate is a fraction. They usually involve units, like so many miles per hour, or so many miles per gallon, or so many problems per test. So let's just take a few. Looking at that example where it says 9 miles over 12 miles, the ratio that is expressed here is essentially 9 to 12, which can be reduced by dividing 3 on both of these to 3 over 4. Now, other ways of writing that same thing or same idea as a ratio is 9 to 12 or 9 to 12, 3 to 4, 3 to 4. Those are just all the same kind of thing, just expressed slightly differently. Like a slang or, a way of saying things that we do in, conversation, different ways of saying the same thing. Ratios are typically between same unit items. Rates, however, are typically between different unit items. For example, a rate of 190 kilometers per 2 hours. That's a rate of velocity or how far we get in so much time. And we always do this when we are making a long trip, right? It's so many miles. Google tells me it's going to be 8 hours. You kind of tell yourself, I can go 60 or 70 miles per hour usually. We always do that kind of intuitively in our heads. That's what's going on with a rate. And this one is telling us that we're traveling 190 kilometers every 2 hours. Now that's just a general rate. If we want to convert it to what's called a unit rate, then basically what we're trying to do is force it to be one, or a unit, 1 unit on the bottom. And how we do that is exactly how we were doing earlier, just division. 190 divided by 2. So 95 kilometers every 1 hour. And you might also see unit rate just reported kind of like this, 95 kilometers per hour, or written out even, 95 kilometers per hour. Let's look at that quiz item number 4 for some context on that kind of thing. It says write $78 for 15 ounces as a unit rate. It looks pretty expensive, right? Maybe we were talking about truffles or something. And so $78 for 15 ounces, a unit rate means I want to know how much for one. How much for 1 ounce? 78 every 15 ounces. How much for one? I'm going to do that division. 78 divide 15 for 5.2. $5.2 per 1 ounce, which makes more sense since we're talking about dollars, right, to write out the pennies place too. $5.20 per ounce. Next little bit that we're going to talk about is percent and how to think of it in terms of decimal and fraction. So if we have 135%, this percent symbol and corresponding idea of percent can be thought of as, okay, 135 per centennial means 100, right? Every 100 years. So that's what percent has embedded in it. That cent part means centennial every 100. So you can think about it kind of like instead of a unit rate, it's a hundreds rate. When you see that percent symbol, everything's over 100, 135 over 100. That's the fraction form. What's the decimal equivalent? Take your calculator out and divide these two. What do you get? Mm-hmm. 1.35. So that's the how of getting to either fraction or decimal form from percent. Now, we later on down the road try to make ourselves do all kinds of little jumps and cartwheels and tricks with percent, right? I look at that and say, oh, I'm moving the decimal so many places. Well, if you're ever not sure, you can just return to the fundamental idea. If it's a percent, I'm going to divide 100. So what is 7 8/9 percent? 7 8/9 percent. Your paper shows you how to go to a fraction, but I'm more interested that you tell me how we would get this to a decimal. You could go that route. However, I know that this is 7 point something percent. What's that part? I can zero in on this and do 8 divided by 9 in my calculator. Get 0.8 repeating. 0.8 repeating. And now to convert further to decimal and do that, I can just leave that in my calculator, divide it by 100, and what do I get? Divide 100. I got to bring the 7 along. Ooh, let me backtrack there. Don't use what you just had in your calculator. Instead, do 7.8888 divide by 100. What do you get? Good. 0.0788. Notice that's a little bit different than this, right? This has whole number in its decimal form. Notice that's over 100%. So that's where a whole number comes into play for a percent. This is a single digit percent. And so when we convert to decimal, it has to have a placeholder here, a 0 here. That's why if I'm trying to do this with tricks, then I need to think about this, boom, boom. I need to introduce a 0 here. But I'm purposely not doing that mental trick with y'all because I want you to really get grounding in the fundamental. Percent means divide 100 if I want to get it to decimal form. Now, question for you is this equal to 0.0788%? No, it's not. This is the percent form. This is the decimal form. So don't scramble the two after you've done all this work. Then what you're doing when you divide 100 here is you're converting it so that it's no longer in percent form, strictly decimal form. So this is not the case. Okay. The 66 and 2/3%. Yep. 66 and 2/3%. Was item number 10. And that does explicitly say to do it as a fraction. So let's talk about that. Just for reference, let's look at the decimal real quick. 2/3 divided in my calculator gives me more sixes, right? And then by dividing this by 100, I see that the decimal form is this. Okay. Now let's talk about fraction form. 66 and 2/3. That mixed number converted to a fraction. Remember, we take the number times the denominator, add the numerator, place all of that over the original denominator. And that's the percent. This is 66 times 3. Do that part in the calculator. 66 times 3 plus 2 is 200 over 3%. Then percent means over 100, right? The 200, we've got a 3 already on the bottom. If we're introducing another number like that and just assume it's times in there, and then that comes out to 200 over 300. Can divide some hundreds there for 2/3. You can check in your calculator that those are equal. I'm more interested that you can go there than the fraction form. Okay. So if you understand the decimal route, that's what I want to highlight, the decimal route. I know your paper says to do that one explicitly as a fraction form, but I'm more interested that you do as a decimal. And so just to recap, the decimal way, we divide this part to get the decimal part here. 66 whole part is over here. And then we divide this by 100. let's go ahead and try to go from decimal or fraction 2%. So kind of the reverse of what we were just doing. For example, if we had 0.875 and wanted to go to percent form, if we want to introduce the percent sign to the decimal form, then we basically do times 100. The opposite of what we were doing before. We were dividing 100, right? Now we're going to times 100, and so that's 87.5%. That's the route for decimal 2%. Then for fraction 2%, look at 1/15, 2%. Same deal. 100 times 1/15%. So notice in both cases, we're just doing 100 times. Now, I would do this part first, however, in your calculator, 1 divided by 15. I think that's going to be a simpler way of kind of making your library of thoughts for this simpler. Do 1 divided by 15 here, and write down the decimal form for yourself. .06 repeating, you see that? So this is 0.0667. Then I do times 100 on that number, and I get 6.6 repeating percent. Suppose I want to round to nearest tenth of a percent. I need to be looking at my percent form and the 10th place of it. So here's the 10th place of my percent form. Then round up, because this next place is a 6, I'm going to do 6.7%. The reason I throw that up there is because that's a very common ask in class in the fall. If you see nearest blank of a percent, you want to make sure you're in percent form first before you do that rounding. Because notice if we did that rounding back here, this place would be 1. And that's a much different answer, 10% in the end. If we rounded this to 1 and then did 1 times 100, we'd get 10% instead of 6.7%. If you see that of a percent part, wait until you're in percent form and then round, rather than back here. We'll pick up next week with the rest of packet 4.